Assalamu alaikum wa rahmatullahi wa barakatuh. Today's lesson about the one of the types of conic sections, which is called the ellipse. We already learned one conic section before called the circle, but today let's define the ellipse. The ellipse is a set of points x and y. All these points x and y has two different distances, one for focus 1 and one for focus 2. The two foci for the circle, okay, already has a distance to any point and one other distance to another to the same point. The ellipse contains two axes, one called major here and one called minor. The major axis between the two vertices and the minor axis between the two called co-vertices. One center, again, two foci. Two foci, one center, two vertices and two co-vertices, one major axis and one minor axis. Let's see here the standard equation for the ellipse. If the ellipse is horizontal, so 2a is the distance between the two vertices and called the length of the major axis. 2b is the distance from or between the two co-vertices and called the length of the minor axis. If the ellipse is horizontal, so our equation is, don't forget, h and k is the center coordinate. So x minus h squared over a squared plus y minus k squared over b squared equals 1 is the equation of the ellipse when it's in the horizontal position. X minus h squared over b squared plus y minus k squared over a squared here, if it's vertical what? Ellipse. Let's see here. If the ellipse is horizontal, so if the ellipse is horizontal, this distance called 2a. Okay, and this distance is the minor axis called 2a. A will be with x. A will be with x if the ellipse is horizontal. But A will be with y, B with x. A here becomes the vertical major axis, but now the horizontal axis called minor. So x minus h squared over b squared plus y minus k squared over a squared equals 1. That's why I can differ between the ellipse in the horizontal position and the ellipse in the vertical position. Again, please, in the horizontal position, h and k the center. So the center here is h and k. So x minus h squared over what? Yes, for the horizontal, a squared plus y minus k all squared over what? For the horizontal, b squared, and vice versa. Here x minus h squared over b squared plus y minus k squared over a squared equals 1. I'll give you the center, h and k, it's okay. I'll give you one of the parts here, b or a, to determine the other, and we have another rule to determine one in terms of the other. If the ellipse has a center origin point, if the center is the origin, so our rule becomes very easy. It becomes x squared over a squared in case of horizontal plus y squared over b squared equals 1. But if the ellipse is vertical, so it becomes x squared over b squared plus y squared over a squared equals 1. Don't forget here the focus. The focus, okay, the two foci lie on the major axis. The two foci lie on the major axis. Here, C. Here, B. And here is A. This distance from here to here is the same here. So C squared equals A squared minus B squared. So we have a relationship between the focus distance, the length of A, which is the center, from the center to the vertex, and the length of B, which is the distance from the co-vertex to the center. Again, we have to know that here is C. Here is C, the distance. Here is B, and here is A. So again, please, C squared. If you want a C squared, it's A squared minus B squared. Let's see how. Now we wanna the standard form of an equation of ellipse having a foci 0, 1 and 4, 1. The major axis length 6. Okay. Here is the focus 1, 0, 1, 4, 1, 2 foci. Center, I'm gonna bring it. And he said that A is 6. I'm so sorry, the major axis is 6. The major axis is 6, means this length called major axis equals 6 units. So A here equals 3. Okay, the distance of the one focus, letter C, is the distance from the center to the focus. How to determine the center? The center is the middle point between the two foci. So find 0 plus 4 over 2, which is 2, 1 plus 1 over 2, which is 1. So he gave us the two foci. I found the center location, which is 2 and 1. He gave us the distance of the major axis is 6. It means like A equals 3. So again, double A is 6, A is 3. Don't forget, I can determine the value of B. B squared equals A squared minus C squared. We know that B squared equals A squared is 9 minus C squared. How to determine C? C is the distance from the center to the focus. The distance from 2, 1 up to 4, 1, 2 units, or from 2, 1 up to 0, 1, which is 2. So the focus distance is 2. 2 squared is 4. B is root 5. So we have now B, A, and the center. The center is 2, 1. So the center is 2, 1. So I can write the equation x minus h squared, h is 2, over a squared, a is 3, plus y minus k squared, k is 1. Again, the center is 2 and 1. B equals root 5 to it, root 5 squared. So I can rewrite the standard form of the equation in this style. So we have finished our work. But now we can just like rewrite the equation in the standard form. If the equation in this style, and we want to write the equation in the standard form, okay, how can I rewrite this style into standard form? Let's see. It's very easy. First, take the x parts here, x squared plus 6x, plus the y parts, 4y squared minus 8y, and rewrite plus 9 in the right hand side as negative 9. Please here search for a number half the coefficient of x squared. Yes, 9. Half the coefficient of y squared. But please, here, y squared must be pure. So please take 4 as a common here. 4 out, okay. And now it's y squared minus 2y plus half this number squared, which is 1. It's okay, here is 9, and here is 1. Rewrite x squared plus 6x plus 9 in the binomial square style. So it's x plus 3 squared plus 4, y minus 1 squared equals, don't forget, we're already here, don't forget, we're already add 9 here, so please add 9 there. Add 1 here, 1 by 4 here, then please add 1 by 4 there. So the right hand side becomes 4. Please divide by the right hand side. Divide all by 4, here it's 1. Divide here by 4, it is here 1. Here by 4, it's here 4. So this is the standard 4 of the ellipse equation. Don't forget here, it's a squared, so a equals 2. Here is b squared, means b equals 1. And we can determine the value of c, which is root a squared minus b squared. So c equals root 3. As we know here, the vertex becomes negative 3 and 1. Yes. A equals 2. B becomes 1. And c squared equals a squared minus b squared. C equals radical 3. It means like I can determine the foci location. You know that the center location in negative 3 and 1. Negative 3 in the horizontal position. So don't forget it's horizontal because b here is greater than a. Horizontal because b is greater than a. A is greater than b, I'm so sorry. A is greater. A for x is greater than b for y. So it's horizontal. So negative 3 and 1 is the center. Add radical 3 and subtract radical 3. It's okay for you? Just negative 3, add it to radical 3, 1 as it is. It's okay? Another one. The same style. How to rewrite the ellipse equation into standard 4. And now find the center, vertices, foci for this ellipse. Write for x squared minus 8x here, y squared plus 4y here, and 8 in the other hand side. Take 4 common as we said before. So write a number here is half 2 squared, 1. Half 4, 2 squared, 4. Okay. And now don't forget we added here 4. And add also here 4. The right hand side becomes 16. Rewrite this 4. It's x minus 1 squared. This 4 becomes y plus 2 all squared after factoring it. Divide all by 16, please. So it seems like x minus 1 squared over 4 plus y plus 2 squared over 16 equals 1. Again, don't forget that a becomes 2, b becomes 4. Right or wrong? No, mister. Here, this ellipse is not a horizontal ellipse. You know, the major number, the greatest number a is 4 root 16, and b here is 2 root 4. So this ellipse is not horizontal, it is like a vertical ellipse. C is root 4 squared minus 2 squared. Again, the center becomes 1, negative 2. Okay, and the foci is the same, 1, negative 2 minus root 12 plus root 12. Root 12 is 2 root 3. It's okay. Can I differ between this ellipse and the ellipse before? Yes. The major axis here is vertical, so this ellipse is a vertical style. Yeah. Center. I can determine the vertices, the two foci, style here for this part. Okay. Thanks for you. And inshallah Rabbil Alameen, later on we're gonna learn something about the hyperbola. Assalamu alaikum wa rahmatullahi wa barakatuh.